Bismillahirrahmanirrahim. Hello, my dear students. I hope you are all doing well. I welcome you all in class of O-level mathematics. In today's lecture, we will discuss a single question that is related to linear inequalities in two variables. And at this time, I have a paper of 2025 O-level mathematics. This is paper 2-3. And in this paper, we will solve question number 15. Yes, this is the question. In this question, we have a grid in which there are the following three lines. This is our first line, this is my second line, and this is our third line. The question says we have to just find the three inequalities that define the unshaded region R. You can see here there is unshaded region R here. We have to find the inequalities opposite to this unshaded region R. Okay. The firstly you will write associated or boundary lines of equations attached with region R. The first line is you can see this is a dotted line and this is a horizontal line. You can observe this line passes through the point y is equal to 2. So the equation of this dotted line, the first one is the dotted line has an equation y equal to 2. This is because this is a horizontal line, so it will involve only variable y. Now these are the two oblique lines, or you can say these are the inclined lines. This is first and this is my second line. Now I have to find the equation of these two oblique lines. This line passes through the 2 points. This is my first point, that is y is equal to 2, and again it passes through x is equal to 2. Actually these are the x and y intercepts. Next we will write the line passes through points. Here x is 2 and y is 0. And this is my second point where x is 0, y is 2. The line passes through the points has gradient also called sometimes slopes, has gradient equal to the formula is y2 minus y1 over x2 minus x1. y2 is 2 and y1 is 0 over x2 is 0 and x1 is 2. I am taking this is y1, this is y2, This is my x2 and this is my y2, and this is my x1 and this is my y1. So gradient is 2 over minus 2, which is equal to minus 1. So the formula to find the line is y minus y1 is equal to, gradient is denoted by m, x minus x1. This become y minus y1. y1 is 0, gradient is minus 1, x minus x1. What is my x1? x1 is 2. This become y is equal to minus x plus 2. This is equal to x plus y equal to 2. Another technique that I have already discussed in my previous lecture. As here two intercepts are given. This is y-intercept. Here x-intercept is 2 and y-intercept is also 2. Y-intercept is also 2. When we have given x and y both intercepts, then the simple formula to find the equation is x over 2 plus y over 2. The number in the denominator represent x-intercept and the number in the denominator represent y-intercept. So this is the simple formula to find the equation rather than this long method. So from here we have equation x plus y is equal to 2. So this is very easy method than this. Now we have to find the equation of the third line. You can see this equation. This line passes through origin and again it passes through from this point. This point has a coordinate x is equal to 2, y is equal to 1. So because this line does not cut x-axis and y-axis, because it just passes through origin, so we cannot use the x-intercept and y-intercept form. So to find the equation of the third line, I will use the process of equation number 2. That is, we will find the gradient of the line. The gradient of third line is, suppose it is denoted by m dash. This is my x1, this is my y1, and origin coordinates of origin are 0, 0. So take this is x2 and this is y2. So formula will become 1 minus 0 over 2 minus 0. This is equal to 1 by 2. So equation of the third line is y minus y1, y1 is 0, gradient is 1 by 2, x minus x1, x1 is also 0. So this is simply 1 by y is equal to 1 by 2x. This is my third line. Now we have to find the three inequalities that define the unshaded region. Okay. The three inequalities are the first one is a horizontal. The horizontal line has equation y is equal to 2. This is line y is equal to 2. You can see that this line is a dotted. So opposite to this line, the inequality is simply y less than 2. We cannot take y less than or equal to 2. We will take equal sign when the line is solid. In case when line is dotted, we will take just less than or greater than sign. Now why are we taking here less than sign only? Why are not we taking greater than sign? You can observe that the unshaded region R is below this line. So that's why when the region lies below, then we take less than sign. So the opposite inequality to this line is y less than 2. Okay. For this line has equation y is equal to half x passes through the origin. As the shaded region is above this line, you can observe that this white region that is unshaded is above this line. So, and this line is solid line. So the inequality opposite to this is y greater than or equal to half x. Lastly, this last line has equation x plus y equal to 2. You can again observe that the unshaded region is above this line. So opposite inequality for this line is yx plus y greater than or equal to 2 here. So the three inequalities are, first one is y less than 2, second one is x plus y greater than or equal to 2, and the last one is y greater than or equal to half x. Further, you can write it as 2y greater than or equal to x, or you can write 2y minus x is greater than or equal to z. Next, for just your satisfaction, you want to check whether these inequalities, three inequalities, are correct or not. You can take any test point. Take any test point from this. Verification is not a part of the question. It is just for your satisfaction. Take any test point from region R. Suppose we take here y is 1.5, that is 1.5, 3 by 2, and similarly here my x is 3 by 2, 1.5. So this point clearly lies in region R, and the coordinate of this point are 3 by 2, 3 by 2. So take any test point for region R. Take x is equal to 3 by 2 and y is equal to 3 by 2. Put these points in these three inequalities and check whether this point satisfy these inequalities or not. So when you put x is equal to 3 by 2, that is actually 1.5. In the first inequality, this becomes 1.5 less than 2. This is true or false? This is true. When you put x is equal to 3 by 2, y is equal to 3 by 2 in your second inequality becomes 3 by 2 plus 3 by 2 greater than or equal to 2. 3 by 2 plus 3 by 2, 1.5, 1.5, this is equal to 3. 3 greater than or equal to 2, this is true also. So the test point also satisfied this inequality. Lastly, when you put this point in your last inequality here, this becomes 2 into y is 3 by 2, minus x. What is x? X is 3 by 2, greater than or equal to 0. 2 times 3 by 2 minus 3 by 2, this becomes 3 by 2. And 3 by 2 is greater than or equal to 0, this is also true. As this point that we have chosen from region R satisfies all of the inequality, it means we have correctly written our inequalities. For example, if one of the students mistakenly write it as this inequality as x plus y less than or equal to 2, then after verification, he can observe that this test point does not satisfy this inequality, and from here he can change the sign of the inequality. So in the next lecture, inshallah, we will discuss some more past paper questions related to this topic. If you find this video is helpful, kindly like, share and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.